Hello everyone, this is Unit 3, Day 9. Alright, just thought I'd record the video for you guys so you guys could use this as a reference in case you need to go back and verify that you understand how to solve these problems, okay? So when you're completing the square, right, beforehand we have done completing the square, but we've been kind of not really skipping a step, we just haven't had to deal with it yet, okay? And so in this particular lesson, we're going to be dealing with a particular problem or an equation that we haven't necessarily seen, okay? But the process is still very similar to completing the square. It's just one extra step, okay? So if you look at your steps, it says complete the square steps, right? So isolate your constant term, which we have been doing, right? As you can see in number 1, okay? They've already moved that constant to the other side. How nice of them, okay? Now the next thing we have to verify, all right, is that our leading coefficient, or that number that comes in front of that x squared, must be a 1, okay? Not a negative 1, okay? Not anything above, just a 1, okay? And so as you can see, again, number 1, we already have that taken care of, okay? Unfortunately, we haven't seen any problems where we've had to deal with this mess, okay? And it basically involves dividing all terms by that leading coefficient, okay? And so I will demonstrate that down the road here. And then everything else is the same. You take your b value, divide it by 2, square it, and then add it to both sides. Okay? And this creates a term we haven't used yet, what we call a perfect square trinomial. Now remember, what is a perfect square? Perfect square is, you know, something like 4 times 4, which is equal to 16, right? Or 3 times 3, which is equal to 9, right? What makes these things similar is that it's the same number, okay, 3, 3, 4, 4, being multiplied by itself twice to create these numbers on the right, okay? So when we're talking about perfect square trinomials, okay, we're talking about when we factor our equations, okay, we're looking for something where we're getting the same binomial written twice, okay? All right, so that's what it means to be a perfect square trinomial, and then after that, well, we've already kind of talked about that, factor the polynomial into this so that we get something like this, as you can see below, and then solve the resulting equation, okay? So, anyway, the only step we haven't really had to deal with is just letter B, okay? So without further ado, let's get started here, okay? So this is hopefully a little bit of a review in the sense that we have covered problems like this, right? Our constant's on the other side. We have a leading coefficient of a 1, and so therefore we're good to go, right? So all we got to do is take our b value, which our b value is 4. So we're going to take that b value, we're going to divide it by 2 and square it, okay? Now you'll notice I always take this extra step here, all right? As you can see, I wrote out 3 steps there. Now you could basically, you know, knock this out in one shot, right? However, I'll show you why I always kind of solve it like this. So anyway, so this value right here, okay, this 4, is what we're going to add to both sides, okay? And so by doing so, what we have created is that perfect square trinomial, all right? So I'm going to combine like terms on the right. All right, now we have our perfect square trinomial, okay? And this number that I kind of left floating out here, this 2, all right, will always be the number that will go inside your parentheses here. And that's a positive 2, and so I put a positive 2 inside there. All right, now let's verify, okay? 2 plus 2, well, that's 4, and then 2 times 2 is also 4. All right, one of those strange coincidences. We don't get too many numbers. Actually, I don't think there is any number other than 2 that has that sort of property. You add them together, you multiply them together, you get the same thing. All right, so anyway, now we have our perfect square trinomial. I combine these two guys so that I get x plus 2 squared, right? It's a perfect square. And then finally, we take the square root. So we get x plus 2 is equal to plus or minus the square root of 12, which I am going to simplify that. It's going to be 3 times 4, 2 times 2. Here's our hockey stick. Bring out the 2. leave the 3 inside. Okay, and then finally subtract that 2, all right, and we get x is equal to a negative 2 plus or minus 2 square root 3. Okay? So, and we can leave it like that, all right, because notice it just says solve, right? Now, if they tell you to leave it in, decimal form or radical form, okay, you got to be careful with that, all right? You got to pay attention to the directions here. Now, I understand that this is 2 answers here, but if you prefer to write it out as 2 answers, all right, just to kind of remind yourself that we have 2 separate answers there, you may do that as well, okay? But if you want to leave it like this, I understand that there is 2 separate answers there, okay? So, anyway, that's number 1. Okay, number 2, all right, is a little bit different. Okay, now, it's very kind of them. They moved that 27 over to the other side. However, okay, when we get to letter B, all right, we don't have a leading coefficient of a 1. We got this negative 3 here. And so what we can do is we take everything and we divide it by this negative 3. Okay, so by doing so, this becomes x squared, this becomes minus 8x, and this is equal to a negative 9. So our constant's on the other side. We have a leading coefficient of a 1, and now we're ready to go. Okay, so I take this negative 8, divide it by 2, square it, and I get a positive 16. So I want to make sure I add 16 to both sides. And 16 minus 9 is 7. And now again, we've created this perfect square trinomial. Okay, and then this number is what's going to go in your parentheses. It's got a negative there, so make sure you bring that along. But let's make sure, all right? Negative 4 plus negative 4, well, that's a negative 8. And then negative 4 times negative 4, positive 16. We're good to go. X minus 4 squared is equal to 7. Take the square root, and we get x minus 4 is equal to plus or minus square root of 7. Lucky for us, 7 is a prime number. We don't have to simplify that guy. We just add 4 to both sides. And we get that. And again, I recognize that there's 2 answers there, but you need to make sure you include that plus or minus. Okay? You need to let the reader know that there is 2 answers there. Okay? All right, let's take a look at number 3. Number 3, just a couple more extra steps, right? We still have a constant on the left side of that equation, and then we also have a leading coefficient of a 2. So we're going to have to take care of that. All right? And so I'm going to subtract 5 from both sides. That cancels there. All right? And then I'm going to divide by a 2. So I get x squared minus 8x is equal to a negative 20. And again, we've already seen this guy, right? Negative 8 squared, or negative 8 divided by 2 squared is going to give me a negative 4 squared, which will give me a positive 16. All right, so that one shouldn't have been too trivial. We've already seen this sort of expression on the left. So I'm going to go x squared minus 8x plus 16 is equal to a negative 4. So as you can see, we have a negative answer on the right. We haven't seen that one yet, and that'll play into some of these past lessons that we talked about before break. Okay, so again, it's going to be x minus 4, x minus 4. Bring those bad boys together and take the square root. Okay, so now we are left with x minus 4 is equal to plus or minus the square root of negative 4. Bring over that 4, and x is equal to 4 plus or minus the square root of negative 4. Okay, now however, we haven't quite solved this yet, right? We got this negative 4 underneath our radical, and so how do we handle that? Well, anytime you see a negative underneath that radical, first thing you want to do is bring out that I value. Okay, letting us know that this is some sort of an imaginary number, right? Because we can't have negatives underneath the radical. And then what's the square root of 4? Well, that is 2. So negative 4 under the radical is just equal to a 2i. And so I switch that back, so I get 4 plus or minus 2i, and we have to leave it like that, okay? Because I is an imaginary number, so there's no way of coming up with any decimal or anything else for that. Okay, let's take a look at number 4. All right, now this one is not asking us to solve. We just need to come up with what number or what value of c will make this a perfect square trinomial. Easy peasy. Take that 6, divide it by 2 and square it. We'll end up getting a 9. Okay, and so x squared plus 6x plus 9. All right, and then as you can see, if we were to factor this guy, we would get x plus 3, which is a perfect square trinomial. So therefore, c is equal to 9. Last but not least, okay, Sam started solving a quadratic using completing the square. What was the value of c in Sam's problem? Finished solving the problem, okay? So first we need to find out what c is, okay? So same process we did in the last problem. I'm going to take that b value, divide it by 2, and square it. So we get negative 7 squared, which is a 49, okay? So in order to solve this, I need to add 49 to each side, okay? Oops, we have that value for c, sorry. And actually, I'm just going to add those two things together. So negative 8 plus 49 will give me a positive 41, okay? Now we have a perfect square trinomial. Okay, take the square root. Go to 41, add 7, and x is equal to 7 plus or minus the square root of 41. It doesn't say anything about putting it in decimal form, and so I'm going to leave it like that. Okay, and so that is completing the square. All right, hopefully this video helps for those of you that are watching, and have a good day.